Okay, hi, welcome back. So for this one, this is just an example of finding the likelihood ratio test and also setting K in the rejection region. So um, the example says we have n, sample size n, that's normal, with mean mu unknown and variance 1 known. H0 is mu equals mu 0, a particular value, and HA is mu is not equal to that value. Find the LRT and set K so alpha equals 0.05. Okay, so just a pretty straightforward example just to see that we understand the definition. So to start, we have Ly, right, is the ratio of the two likelihoods. Okay, the likelihood over the first over the set of mu under the null hypothesis. So what possible values can mu take on in the null hypothesis? That's right, just one value. So the numerator is just the likelihood of the sample y evaluated at mu 0. Now the bottom, I can take, in this case, any real number because it's the composition of those two hypotheses, the union of them. So what is the likelihood, what value of mu would maximize the likelihood? So normally we'd have to compute this, but we know this because we did this in the section on maximum likelihood estimators. Well, maybe you missed it, or maybe I didn't do it, but I think I did it, and we found, and if not, you can certainly show that the likelihood, if I don't restrict mu at all, is at the sample mean. So this becomes, okay, and let's just write y bar is MLE of mu, and this was found in chapter 9. Okay, so that just saves us a lot of steps to actually find that. Would be a little bit of a problem. Okay, so let's write out the likelihood function. So I have n of these, so it's the product of the PDFs now. I evaluated these mu's here. So I get 2 pi, remember sigma's 1, so minus n over 2. Exponential function 1/2 sum 1 to n yi minus mu 0 squared divided by 2 pi minus n over 2 exp minus half 1n yi minus y bar squared. Okay, and this is equal to, these two terms cancel, and I get exp minus a half. And these would then add right in here. I have, or subtract because I'm dividing. So this would be, right? And I can do it all in one. I can reuse the indices too, right? Because these are all contained like this. So I could write it like this, 1 to n yi minus mu 0 squared minus yi minus y bar squared. And these all go in that sum there. Okay, and let's keep going. Equals exp minus a half sum 1 to n. The yi squared terms go away, right? And I have minus 2. Yep, so I get minus 2 mu 0 yi plus mu 0 squared. I have minus 2 y bar yi minus y bar squared. All right, I just multiply those out, and I canceled the yi squared terms. Okay, which equals, this is just algebra, I'm afraid, minus a half Now, let's see. If I apply this across here, these are constants, so these are kind of not too bad. These come outside, so I get ny bar here and ny bar here. So the summation's gone, right? I have minus 2 mu 0, minus 2n mu 0 y bar. That's this. This one becomes plus n mu 0 squared. This becomes ny bar, so I have minus 2 ny bar squared. And this one becomes, and this should be plus, right, when it comes across here. So this is plus. Oh, nope, it's minus. This one's plus, right? Everything seems so magnified when you make the videos and you make a mistake. On the board, you would definitely catch this stuff and tell me. But so, yes, it looks right now, right? This should be plus, this should be minus, this should be minus, this should be plus. Yes, looks right. So this one here should be plus, and this one here should be minus n y bar squared, right? Yep. Okay. All right, so from there, we can keep going, simplify it a little. Let's see what happens. We get this equals exp minus a half. The n can come out everywhere too, so I have minus a half. The n comes out. And what do I have here? I have minus 2 mu 0 y bar plus mu 0 squared. I have plus 2y bar squared and minus y bar squared, so it's plus y bar squared. And you recognize here you have a square. So this is exp minus n over 2 mu, let's put the y first, y bar squared minus, y bar minus mu 0 all squared, right? Y bar squared, mu squared, and here I have minus 2 mu 0 y bar. All right, this is it. And this is the likelihood ratio, right? This is the likelihood, the ratio of the two likelihoods. Look, this is a good moment because, here, I'll write this here again just to remind you, this is the ratio of the two likelihoods. So what you can see is that the further y bar is from mu 0, the bigger this term is, it gets squared. Okay, it gets squared. And it gets multiplied by minus n over 2. So it gets squared. If this is less than 1, then it would get smaller. But if it's bigger than 1, it gets bigger. Think about that. But if we think about it, this is being getting bigger, then this makes this more negative. It makes the whole thing get smaller. So the further, if I think for bigger than 1, the further y bar is from mu 0, then the smaller the ratio is, and the more likely I am to reject that mu equals mu 0. So this looks good. Looks good. So this looks good. So looks good. So let's just write that. So remark, note farther is from mu 0, the smaller is lambda y, and the more likely we reject H0. Okay, makes sense. Makes sense. Okay, let's go a little further with this and see, like finish it. We want to find k. Well, I'd like to simplify maybe the test too. Okay, I want to see how much time. Okay, well, so because okay, so here we are here, and we would like to maybe simplify this. I'm going to actually stop this, and you can watch the next lecture. I don't want these to get too long anymore. All right, so click on the next lecture to find K and see the simplification, and for more discussion of this problem.